Good morning, everybody. This video is a little different. I'm making a screen recording of this lab activity that I want you to complete. So this lab is in the content library. I think I pushed it out to you. It's just said lab graphing equilibrium. This is an activity that we would have done in class. It's pretty simple. You could pretty much replicate it at home. The idea behind this is to show you how a system can start out not at equilibrium and establish equilibrium. So the materials that we would have used, let me change this. We would have used two large beakers, 1,000 and 800. We would have used a couple of smaller beakers. I usually use 50s, but it doesn't really matter. And so what we would do is, following this procedure, we would put 500 milliliters of water into the 800 milliliter beaker. That's this one. This represents the amount of reactants that I have in my reaction. And at first, I have no products, right? Because I haven't done the forward reaction yet. My goal is to get my reaction to establish equilibrium. Excuse me. Then what you would have done is you would have taken a small beaker and you would have scooped out as much water as you could out of our reactants and quote unquote reacted them to make products. So we'd have poured some water in there. Then we would have taken another tiny beaker, and so we would have had like a little bit of water at the bottom here. And without tilting this large beaker at all, we would have tried to scoop out as much as we could from the products and turn it back into reactants. Now, obviously, since we don't have very many products, this initially is going to be slow because there's not much in it. This forward reaction is going to have a lot of transfer occurring. It's going to be pretty fast because there's a lot of reactants present in our system. So what we would have done is we would have tracked the changes in the volumes as they, as we kept accumulating product, we could keep scooping back more, and we would have tracked the changes. So I'm going to just fill in this data table. So we would have poured from reactants to products, from products to reactants, and then recorded the volume. So initially there were 500 milliliters here. There were no milliliters here. What you probably would have seen after a transfer is about 480 here and 20 here. And then after another transfer, maybe we'd have like 450 here and 50 here. And after another transfer, maybe like 430 here and 70. So I'm just going to fill in based on what normally happens during these trials. And then what you would have seen over several trials is that once you've accumulated enough product in your product beaker, you're able to scoop it all back into the reactant beaker. So you see your numbers are leveling off, okay? So what I want you to do here, underneath the lab worksheet, I attached a piece of graph paper. So I want you to graph this data. You're going to make two lines. One line is going to be for the reactant volume changes versus the trial number. And the second line is going to be for the product. So you would have to do 12 trials. You don't obviously have to fill up to 20. It would stay the same. So on your x-axis, you just put an axis on here neatly. This would be trial number. So this would go from 1 to 12. And this would be volume. And this would go from 0 to 500. And you would have two lines on this graph. You can make them different colors. You're going to connect, all of your reactant dots together and then all your product dots together to show that your two lines are on here. Here's, how you would graph this. So once you do the graph, you just have to answer the questions. The point of this is to show you that right here, Equilibrium is reached when the rate of the forward reaction is equal to the rate of the reverse reaction. Before equilibrium, the rates are not equal. So that means that they're getting faster or slower over time as they reach equilibrium. I also want you to make note of what happens to the volumes. So when we looked at the concept of equilibrium, we know that the rates are equal. We're going to pretend the concentrations are the volumes are concentrations. Okay? So just keep that in mind as you go through this activity. I'm going to post this to Edpuzzle, but since it was being weird yesterday, I'm also going to link this YouTube link right in this page in OneNote.